Anyone can help me recall what we covered in the previous session? Rajkumar,
Yes, sir.
can you please help me recall what we had in the previous session in our class, like before the project review?
Sorry, sir, I forgot what the program.
Okay, did I cover the arc phase with CLI interface? We covered CLI from online interface using arc phase tracer. Oh, fantastic. All right, thank you, Hardik. Thank you, Raj. All right, now moving to next chapter. So in this chapter, we're gonna learn how to improve the script efficiency. So we're going to understand what script efficiency means and identify simple ways to measure the performance of Python code and use appropriate data structure for better performance and also apply basic techniques to optimize loops and operations and also recognize the importance of efficient algorithm. All right. So hello once again everyone and welcome again to our session. So we had our Python project review. So if you ask me what's my insight of the review, then honestly speaking, most of you guys have used the help of the AI, which is okay. But getting the help of AI is something different than getting the AI to do the work. It's like you guys are not even learning anything, it's just like copy pasting it. And many even we're so lazy to even comment off like write off those AI comments. Which is not appreciated, guys. Like it's all on you. You can use AI. It's not very like restricting you, but try to learn from it. Get the help, not make it work for it. So today we're going to talk about something very important as a Python scripts. get bigger and do more work. That is called script efficiency. So what is efficiency? So when we talk about efficient script, we usually mean two things. One is time efficiency, that is speed, like how fast does your script run? Does it take a seconds, minutes, and hours to complete a task? Now guys have been running short, like very short scripts. There's a span of a second, a couple of seconds, or 10 seconds. But what happens when they have hundreds of, like thousands of lines of codes? So all depends on how fast the script runs. And the second thing is resource efficiency. First, time efficiency, and second is resource efficiency. So how much computer memory and CPU power does your script use while it is running? So many says Python just like the processor and the RAM is just depends what type of, like how efficient your code is. So these two things is what makes your code efficient. So today we might have a lot of theoretical class and a little bit of coding class. So guys, this is one of the important solutions which might help you because we all know that. Okay, can anyone tell me what um, defines a best coder with a good coder? Like a one task is given to one two guys, and how do you define? Like they are completing the work, they're completing the output, they're giving the same output A plus B. But how will you define whose code is the best? Can anyone tell me that?
Sir, less number of code and code offline and less errors.
Perfect, Akansha. And
which takes less time to run the code.
one other point. And you guys are missing out one thing. Yes, Prakash. The one main thing that word starts with you. Unique, guys. It's unique. If you give your Python, like if you give Python project to a couple of people, and what defines someone is like getting the output done, but in a more unique way. That unique include being fast, efficient, less like less is better is something this is coming up nowadays. And the main thing is being very unique, like having a lot of feature which others code doesn't have. Yes, yes, Kevin. Perfect. Yes. So why should we care about efficiency? The first thing is user experience. It's all about providing our client the best user experience. Like faster script means user that don't have to wait as long because nobody likes to wait nowadays. And the second is resource cost. Inefficient script can consume a lot of server. Like Python code, not all the Python code run in local machine, but all comes in the AWS. So like, what server do you run? So more the code is, more the heavier it loads on the server. So inefficient script can consume a lot of server resources, which can cost money, especially in cloud environments. The next one is scalability. Efficient scripts are more likely to handle large amounts of data or more users without flowing to a crawl. Like if you see Instagram is solely made with Python, it has a good server, but sometimes it crashes in the peak hours. What happened in a lockdown period, Instagram was so quiet, slow, because it has a lot of people using it. So many were like jobless, right? The third is like the fourth thing is good practice. Writing efficient code is a hallmark of a good programmer. So today we'll focus mostly on time efficiency. I look at simple ways to make a Python code run faster without making it overly complicated. All right. So before we can improve efficiency, let me ask you guys, how do you know if your code is efficient or not? Can anyone answer this question? Anyone answer this simple question, guys? We were speaking about efficiency, it's like time efficiency. How will you know that if your code is efficient or not? How will you calculate that?
By using time and space.
Exactly. So before we can improve efficiency, we need a way to measure it, right? How do we know if one version of our code is faster than another version? What happen if the latest update we have released, but that update is slower than our previous thing? So this is the simplest way to time it. So for example, let me show you. All right. So Python's built-in time module is great for this. So we're gonna import time. So I'm gonna give start time and run time. So this is where how its time gets started. Now a simple loop. Let me say the total is 0, and for I range I give okay. Okay, let's take this thing, and I give iterate total with 1. Now I'm ending the time. Now let's see range total time. Okay. So how do we calculate total time? Our code took nothing but and total. So let's try to run this thing. Simple code. This is the math, and this is seconds. So start time records the current time in seconds since a specific point in the past called the approach here. So before, this is where they say this is where you start your code. The code instant happens, it starts. The duration is nothing but the end time minus start time. Calculate the difference between, which is like how long your code took to execute. Here is in milliseconds. So you can use this kind of simple pattern to compare different approaches to solving the same problem. Run the code with one approach, note the time, then change the code to another approach and compare. So this method is good for quick change. But for very short operation, it might not be super accurate due to system overhead. For more detailed analysis, Python has the timing feature, profilers like C profile. But here the time model is like great for starting point. You can use this. So this is the time module. Just start and end time and calculate the duration. That's it. So if you are running a, let's say, Selenium automation, and you are giving a one task, and they're like it has to repeat 10,000 times, and the one task can take 1 minute, sorry, 10 seconds. The another can take 15 seconds. Now you have to calculate the average time. With the average time, you have to calculate the estimated time. So that's how you calculate time and improve your efficiency of the code. So also in multi-threading in Selenium, you have to know how many pods should I use to make the script faster. For example, if I use 10 pods, the script is like 5 minutes faster. If I use 11 pods, it is 6 minutes faster. But if I use 12 pods, it gets down to 2 minutes faster. Likewise. So it's like a bottleneck threshold limit. So how it gets calculated is by knowing the time. This is one of the efficiency we can use. Any doubt, people? So there are the different types of format available. You can check in stack or any variables. So it's a simple thing. All right. Now we have seen about timing, calculate the timing efficiency, knowing what the efficient time is, knowing the threshold, bottleneck, and goes on. Now coming to efficient data structures, like lists, should I use lists, or when to use sets or dictionaries for lookups, and goes on. So choosing the right data structure can have massive impact on performance, especially when you're searching for items. For example, you have your Excel sheet or this common separated value CSV, and there are like 20, okay, 2 lakhs or like say 20 lakhs, 30 lakhs of rows. And you're trying to search something, search particular type of IDs, particular type of like, for example, who stays in this state, who stays in that, etc., etc. At that time, your code won't happen instantly. It depends on your CPU, it depends on your RAM, it depends on how your code efficient is. So if you have a large list and you want to check if an item is in it, Python has potential to look through every single item one by one until it finds it or reaches at the end. So this is called linear search. Python has linear search. It doesn't go on the whole, it goes line by line. For better, let me share you an example using the lace and the time together. Let's see that how it works. Okay, let me more time 1 second. And I have a large list. Okay, this is one example. And list and giving range of like, oh, 1 lakh. And I want to find an item. Okay, let's say triple. Okay, so it will go at the end. So an item near the end here. So I'm going to start the time. Time get started. Now, if item to find in last list, okay, that is here. Pass. Pass is nothing but just telling the program we know it, stop the code. And now recording the end time and the time duration. So let's see that. So we'll take a couple of seconds. You should have, I should have shortened the code. So no issues, let me explain that. So I have important time and I have open a variable which has large list. And in that list, I want number, every number with a range 0 to 1 lakh. Okay, 10 lakh like this. And I want to find the item as 99 lakh, 90, 999999. And I'm giving the start time. So I'm giving the condition if the item to find that is a 9999 in large lists range between like 1 to 1 lakh found, pass it, like just pass in the code. Done. So you don't have to go beyond that. And I'm recording the end time of the code. I'm now to calculating the total time by the ending time and starting time in seconds. Rogar is running. Maybe I'll give it a large set, I guess. So let me reduce to. Okay. You see the difference here. I just keep one. It is in minus. Likewise, guys. But in sets and dictionary, checking for keys in Python or implements using technique called hash tables. So this makes checking for membership, like if an item exists in like on fast on average, it doesn't matter how much large the set or dictionary is. The lookup time is roughly constant because the dictionary in keys values it's very easier to find. Like looking up in Excel because I will look up. So let's just check that. I'm going to go with time once again, and I have large case of set. Okay, now this time we'll use same thing as range. Okay. So I'm converting the list to a set here and do the same thing what we did before, but using set instead of a list. Are you guys able to understand what I'm doing? So here we convert our list to a set. So this conversion takes some time itself, but if you're going to do many lookups, it's often worth it. So if item to find a last set, so it's checking for like a membership in a set. So let me just copy this one and let me run you guys two things simultaneously. Set copy. Same value, the list and a set. Just look at the time difference. This is faster if you see. So when to use which? So leaves, it's good if you need to maintain the order of items, allow duplicates, or frequently add or remove items from the end. But instead, it's excellent for fast membership, testing like checking which item already exists, or removing the duplicates or performing mathematical set of operations like union, intersection. But here, order is not guaranteed. It might be like a jumbled. Accordingly, order is guaranteed. In dictionary, perfect for storing key value pairs and looking up values is very quickly because rather than searching the whole thing, it will just search the key and give the value of that key value. That's it. Any doubt, people? All right, Hardik, I see you have typed everything in caps. Okay, Hardik, don't mind me, plus, can you please explain me what you learned by just seeing the two exit and just tell me the two things here. What did you learn from these two things? Come on, Hardik. Yeah, I just want to make sure you guys really understood. Or anyone else want to volunteer? I don't. Yes, Gus, but can you explain me why? Yes, Akansha, rather.
So, because of using different types of data types, the difference between time is there.
Exactly. This is good. I hope you guys really understood the importance of choosing the right type of data types. All right. Now moving to, so let's just say we are using a lot of loops. The service seeking item form in the list and how much time it will reach. Mm-hmm. So thick, great. So all the Python codes probably have something called loops and operations. So loops are often where scripts spend a lot of their time until the gets satisfied. The small changes here can make a very, very big difference. The first thing is avoid unnecessary computation inside loops. For example, if you're trying to divide a number with a and b, just divide it directly by using the slash value. But instead, what people do, they use, okay, let me just come another way. A user wants to multiply his number 5 into 5 times. But if your script says add 5 plus 5, 1, 5 plus 5, 2, 5 plus 5, 3, goes to 5 times, has like in loop for I in range or I in some, depends on the program. So using that thing is efficient or just multiplying directly, 5 multiplied by the user input. So which is efficient here? Which kind of loop is efficient here? Obviously the second one. So avoid unnecessary computation inside loops. If a calculation or operation inside a loop always proceeds the same result in each iteration, try to do it outside the loop. So we just in the code. For example, so this is my less efficient code. So I have my list. I don't want to use these big factory problems enough. And now I want to keep their soul as so this calculation is the same every time. All right, this is every time. Every time the code gets run. So for item, for I'm creating a list with a range of 2000 and I'm giving the threshold as 50 multiplied by 2. That is 100. This calculation is the same every time. So for item in my list, if item that is say 1, 2, 3 greater than the threshold is like nothing but 100, pass. Let's just say one way of code. The efficient way, same thing. I don't know how to put this into word, but let me just say. Hmm. Give me a second, guys. I'm thinking how to put this into a good example. I'm not getting that currently. Okay, got it, got it. Oh, my bad. So you can see the difference here. I've created a my list with a range of 1000 and giving a for loop for item in my list and calculating a threshold. So what happens? This thing will calculate each time. But this one, what will happen? This one, can anyone guess how to calculate once? So this is here looping efficiency. So you might not know it might not even make big sense in this code, but when you're running it, like I'm giving a just an example here. So this thing in you like a big loop can make a very big difference timing, like saving the time efficiency. So while this example is like very trivial, just imagine threshold involve a more complex function call in your whole Python, whole code. So instead of moving it in, moving it out make a very big differences in repeated work. You guys have any doubt or you guys understood what I just did here, how the looping thing, like what the efficient and less efficient way? You guys got the point I'm trying to convey? Anyone? I also want to explain this so that I can be sure that you guys really understood. Anyone can volunteer, right? Right. Okay, I assume you guys understood. Okay. So moving to expressions, like let's just say if you're creating very large sequence just to reiterate it over it once, this comprehension might use a lot of memory, right? So we have something called generator expression, which creates items one at a time on demand. So for example, here, so let me just say sum of squares. Guys, if you hate maths, I do hate math, but you have to learn. Sum, let's just say sum, and I'm opening a bracket, and we get this. So, okay, I multiplied by I. For I in the range, let me give the range as 10 lakhs square, like 10 million squares. And print, on. Okay. And now I show the same difference with generator expression. So you might not know, but this thing, when it calculated, it held a lot of memory as compared to this one. Same small square it is in generator experience. Okay. Minute changes. But can anyone tell me the difference? What difference does it have? Exactly, Raj. Yes. So the second thing, I didn't use a square bracket, though this is a generated expression used like using a parenthesis. So it doesn't build the full list of 10 million squares in memory, but it only built on demand. So after this execution, it will just go away. So this will still get stored the list because I have created a list. So the listing is stored in the Python's memory. Like you might not understand, but when you pull up a big program, you know it. So instead, sum here pulls one squared value at a time from the generator and deals and add and just gives the value output and just cleans the temporary file. So this is a great for memory when dealing with huge data sets. So make sure you guys use the generator expression, nothing but using the parentheses when you don't have to use the square brackets. Simple, but it's more efficient. So Python also has built-in functions and library called sum parentheses, map parentheses, filter, and standard library modules often implemented with C and are highly optimized. So prefer them over writing your own version in pure Python if they fit your needs. So example, some parentheses or some like this. So this some this is nothing but it adds a value. It's a faster than a manual Python loop for summing numbers. So using the inbuilt model to use, instead, we are defining the own loop of adding the stuff like we did here. All right. Also, algorithmic choices. So sometimes the biggest speed ups comes not from small tweaks, but from choosing a fundamental better algorithm, like a step-by-step procedure for solving a problem. So let's try to deal with the last example of the day. So this is a example which might cover you. So I'm creating one list as a range. Give me the file. And list two. Yes, Deepika, did you have any problem? Let's make sure I don't tolerate these kind of stuffs. So common elements. Let me just open this. Okay. I might ask someone to explain the code. So guys, I want you to have a look at it. All right. Just see the code here. It has the same output. Can anyone tell me what this kind of loop is called? Like, what is the approach one calls?
Nested loops.
Exactly. Uh, can anyone explain me the difference between the two code and approach? It would be very appreciable, guys. Okay. So the nested loop approach has to do many comparison. For in the sense, say, for item one in list, if item one in list two is comparing common elements append. This is comparing the common elements. Okay. For item is like nested loop approach. Okay. So the item one in list two part itself has a linear search to the list two for every item. The list one. Okay. Like your thumb doubles the code also doubles. And but the second approach, converting to sets and using set one intersection with the set two, just intersecting and it knows what's common, is much faster because the set operations are highly optimized. So this illustration that changing your overall strategy of algorithm can yield big differences in than the micro optimizers. First one, we are manually making the list. The second one, we are using basic commands. Yeah, yes, I agree. But also in the first thing, we are going with linear, checking if the item that is one exists in list two, that too by linear search. But in approach two, we are just using the intersection method, like set one intersection, and we are finding out what is common in between two. That's it. One set of code. Hope you guys have understood the logic behind this algorithm. Does anyone have any doubts? So Yeah, two tips. So don't optimize what needs not to be optimized. Like don't touch what is working perfectly. Don't touch something which doesn't need any optimization. So write clear, correct code first. Only optimize if you know there is any performance problem or there's anything that can be made better. After measuring that time. The second thing is profile your code. For serious optimization, use profilers like C profile. So there is something called C profile. Hope you guys go and check about this in after this session. So C profile to find the actual bottleneck, like the parts of the code where most time is spent. And the string concatenation. For joining many string, use join list of string is generally much more efficient than using the repeated plus operator in a loop. And local versus a global variable, like we discussed in the threshold, accessing local variables generally faster than a global variable within a function, but also calculating a local variable again and again, but global variable happens only once. And catching and memorization, if you have functions that are called repeatedly with the same argument or an expensive to compute time consuming to compute, you can cache the result and store them in a global argument like we did in threshold thing calculation. So you don't have to, so that the code has don't have to recomplete again and again for every loop. So Python functions have something called function tools catch, ALRU catch is a good tool for this. So this is more bit more advanced, but I want you guys to be aware of it. So what that thing is, let me just show you two things I want you guys to cover up this. The first thing is what do you say? Okay. Yes, yes. This one tool. This one. Get to know about these two things. It might help you out. Okay. Today we have scratched the surface of script efficiency. We have known how to efficiently optimize our script. We also got in a little bit of a cheat codes, tips, tricks. So efficiency involves both speed and resource usage. Measure before you optimize. Choose data structure wisely between sets, dictionaries, for past curves, list for order and duplicate, sets for mm, inbuilt rule like intersection. And also optimize loops. Avoid redundant work. Use list of comprehension. Consider generator for larger data sets and try to prefer built-in functions like these intersection functions. And sometimes a better algorithm gives the biggest win in a micro optimization. And to just optimize here and there, just optimize what needs to be optimized. So writing efficient code is an ongoing learning process. As you write more Python, you develop better initiation for these things. So any questions finally, guys? Do you guys have anything to say regarding this session or regarding the project review session? Any feedback or anything we want to share? Garv, that's a nice question. Check the same within HR admin. I've shared the report with them. since I can't say that openly in the front of the class, right? All right. Any other question, people? All right, great. So try applying some of these timing and data structure ideas to scripts you have written or will write in the future. All right, we'll end the session. Thank you guys for listening. Thank you so much for joining and have a great rest of the evening. See you at the next session. Thank you, people. You can leave.